So for solution stoichiometry, what we're going to do is use our molarity formula as a conversion factor. And from the moles, we can either find out the volume or the concentration of a solution. So if we look at a practice problem, what mass of sodium chloride, all right, so we want mass in grams, is needed to precipitate all of the silver ions from 20 milliliters of 0.1 molar silver nitrate. So because this is a 1-to-1 mole ratio, then we just have to worry about our silver nitrate here. So we have 20 milliliters of 0.10 molar silver nitrate. Now because we're wanting mass in grams, our conversion factor needs to be 58.44 grams, the molar mass of sodium chloride. For silver nitrate, what we're going to have to do is use our molarity formula to calculate the number of moles because we have a volume and molarity here. So the way we're going to do that is to set that up, and we have 0.10 moles per liter, all right, from our molarity here. We cancel that with liters, 0.0200 liters, and we multiply that out, and our moles of silver ions is going to be 0.0200 moles. So now we follow through the rest of the chart. So it's a 1-to-1 mole ratio here. It's a 1-to-1 mole ratio here. So we end up with 0 of both of those. And that means that we started with 0.0200 moles of sodium chloride. So then we calculate this by using our molar mass. So we multiply 0.0200 moles times the molar mass, and our answer then is 0.117 grams of NaCl. Alright, so titration is the technique that we use. I'm sorry, that's blocked off. There we go. Titration is what we use as the experimental technique. And we're going to do some of these in class a little bit later on. So a couple of terms to remember. When your stoichiometrically equivalent quantities, that means the number of moles, are the same, it's known as the equivalence point. So the equal number of moles of hydrogen and hydroxide react, and this is typically an acid-base reaction. We use an indicator, which is a solution that changes color when you put it into an acid or a base. So you'll see these in class when we do a couple of them. But let's learn the math first. So here's a typical problem. What volume of 0.115 molar perchloric acid is needed to neutralize 50 milliliters of 0.0875 molar sodium hydroxide? So for this particular problem, because we have the molarity of both of our solutions, that is going to be our conversion factor here. All right, so if we have 50 milliliters of 0.0875 molar sodium hydroxide, and we know we have 0.115 molar perchloric, we're looking for volume, either in liters or milliliters. So to calculate our moles here, we're going to use that formula. So 0.0875 moles per liter times the volume, 0.050. Make sure you're changing those milliliters to liters. We get an answer here of 0.004375 moles. So if we set up our fraction, we get 0 there. We end up with 0 there, which means we started with the same number of moles. It's a 1-to-1 mole ratio. So now we have to use the formula to calculate the volume. So if we know that we have so we can start with our moles, 0.004375 moles. Now using the molarity, remember that molarity is the same as moles per liter, so we can put 0.115 moles on the bottom, liter on the top. And that way our moles cancel. So basically we're dividing, and when you do that math, you get an answer of 0.0380 liters of perchloric acid, or that's 38.0 milliliters of perchloric acid. Alright, so let's look at another one. So what volume of 0.128 molar hydrochloric acid is needed to neutralize 2.87 grams of magnesium hydroxide? Alright, so here we have 2.87 grams, which is why we have molar mass as our conversion factor, and we have 0.128 molar hydrochloric acid, and we're looking for volume in liters or milliliters, so we have to use our molarity formula here. So we're going to first of all change our 2.87 grams to moles by dividing. Alright, so we're doing 2.87 grams times our molar mass, and that'll give us moles of 0.0492. Now we're going to do our fractions here. So this is 1 over 1. So we're going to lose all of those moles and end up with 0. Our fraction here is 2 over 1 because there's a 2 there on the HCl. Alright, we end up with 0, so if we work our way backwards, 2 times 0.0492 moles gives us 0.0984 moles. Alright, so when we want to find the volume here, we have to use our molarity. Alright, so if we start with 0.0984 moles, we're going to end up dividing by our molarity, 0.128 moles per liter. So our answer becomes 0.769 liters, or 76.9 milliliters of HCl. Now, if the question doesn't specify, it just says what volume, you can go ahead and leave that in liters. Sometimes the question will ask you for milliliters. Alright, let's look at one more practice problem. Oh, can't see that. Alright, if 45.3 milliliters of 0.108 molar HCl, so I'm going to put that here and then go back to full screen. Well, you can see this. 45.3 milliliters of 0.108 molar, so we're going to have to use our molarity formula. We are looking for how many grams of KOH. Alright, so grams is mass. We're going to need the molar mass here. And it's okay that this only has 2 sig figs, because when you look at a conversion factor, they have an infinite number of sig figs. So we're going to use our formula here to calculate moles. So to do that, we do 0.108 moles per liter times 0.0453 liters, and that gives us 0.00489 moles. Alright, we have a 1-to-1 mole ratio here, which means we lose all of those. 1-to-1 mole ratio here, which means we started with the same number of moles. So now we just calculate grams using our molar mass. So we do 0.00489 moles times our molar mass, and you get an answer of 0.273 grams of potassium hydroxide.